Hi, boys and girls. You cannot see my face, but you don't need to hear my voice. Today we're going to talk about plate tectonics, and we'll try to keep it to about 7 minutes, and that's where we'll cut the video. So just give me a warning. So before plate tectonics, there was something called continental drift. This scientist named Alfred Wegener thought that the continents kind of just plowed through the ocean floor because we have evidence that there was something called Pangea years ago. Anybody remember what Pangea is?
Yeah.
What's the idea of Pangea? Right here?
It's like when all the continents were all one.
Yeah, all the continents were connected. We have evidence for that. Wegener couldn't explain the mechanism when he was asked, well, how did the continents move to where they are now? And so you know how people are, even if you're onto something, if you can't articulate it, they will refute what you're saying. They'll scoff at you, say you're a hack, you don't know what you're talking about, kind of laugh it off. So that's kind of what happened with him. Now he was onto something because there's evidence to suggest, and we won't get into that, but there was fossils, yada, yada, yada. There was obviously the shape of the continents, blah, blah, blah. But after that, the discovery of plate tectonics teaches us that there are these plates that we talked about last week. Remember, we talked about the different layers of the Earth's interior, this being the crustal region, the mantle, outer and inner core, yada, yada, yada. All right, that's a little review. Now, what we do know now is that the plates, crust and upper mantle and crust, they float on top of what we call the asthenosphere that we're down there, which is the lower mantle. It's, imagine hot gum, if you will. It would get a little more fluid and flexible, and that's what the plates are moving on. All right? These represent the various plate boundaries. Now, in this course, we're not going to hold you to memorize, as I had to, like all the major plates. Not necessary, just knowing that a lot of the plates are named after the continent, right? So that kind of helps. Like, see that? See that? Doesn't take a rocket scientist to figure out where they got their names from, huh? All right. Now, what plate makes the plate move? Now, you and I know that there's two different types of plates, right? What did we say they were last week? There was, what? Yes, you're right, continental and oceanic. So over here, this is showing you how the plates move. So write in your notes, how do the plates move? Well, this is how. By convection currents or convection cells in the asthenosphere. Remember when we talked about the three methods of energy transfer or heat transfer? We said radiation, conduction, and convection. Remember that? Describe how does convection work? Well, down here we think is where the heat of the interior originates. Okay? So this area is naturally hot due to radiation, nuclear decay, if you will. All right? Now the heat given off causes this area to be warm, but the source is here. So do you think it would be hotter here or here if the source of heat is here? Where do you think it's hottest? A or B? A. How did you know? It's closer. Now, because this is the consistency of, almost liquid, but not quite, it gets to, it's fluid. And so what happens is the hot, less dense material rises and the cool, more dense material sinks. And so you get these internal convection cells, okay, on both sides of the plate. and that's what causes them to move at a very slow rate. All right? Centimeters per year usually is what we're looking at. So, what makes the plates move? Convection cells in the asthenosphere that come from the heat of the core. All right? Preguntas? No preguntas. Now, over here, let's talk a little bit about what we see here, because all plate boundaries are not the same, okay? You see the different types of plate boundaries here. You see a convergent plate boundary. What does that say? Transform plate boundary and divergent plate boundary, okay? Those are your three types of plate boundaries. You should be writing. 3 types of plate boundaries. Label them. Convergent, transform, divergent. If you write me a song about the different types of plate boundaries and perform it in front of the class, I'll give you 2 bonus points. I'm a kind man. Speedo, can you put the camera here for a second so the kids can see who the kind man is? That's me. All right, you can put it aside.
Yeah, okay.
They need to see his kindness. All right, now, these are some of the things that happen at these different types of plate boundaries, and we'll talk a little bit about them. All right, just a little bit. So, you and I know the 3 types of plate boundaries, don't we? Yes, Mr. Cunningham. All right? There's something called faults, and we'll talk about that as well, but not as much. So, we already said that, but what happens at the different types of plate boundaries? We just said this a minute ago. You already wrote that down. True? True. Okay. What happens at a divergent is first. At a divergent plate boundary, you get plates moving apart from each other. They're divided.
You're at 7.
I'm just gonna finish.
Okay.
Actually, I'll stop right there. All right, boys and girls, I love this stuff. I hope you love this stuff. See you later. 2 and 2. Peace.